Hey everyone, in this video I'm going to show you how to solve the ALEKS problem called Understanding the Basic Descriptive Vocabulary of Fatty Acids. This problem will give you the structure of a molecule and it asks you to select all of the terms that can be used to correctly describe that molecule. There are three different types of terms in this list. The first four terms are all going to be referring to the type of molecule that you're looking at. Fatty acid versus a mono, di, or triglyceride. The next four terms referring to saturation are going to be describing whether or not you have carbon-carbon double bonds in the molecule. And if you do have carbon-carbon double bonds, you might use the last two terms, omega-3 or omega-6, to classify the double bonds. First of all, going down this list, the type of molecule that you're looking at, I did not look at every single ALEKS problem, but every one that I looked at, the molecule was a fatty acid. A fatty acid is a molecule that has the carboxylic acid functional group, and then it has a long carbon chain. I did not see any examples of molecules that had too short of a carbon chain to be classified as a fatty acid. That doesn't mean that they aren't there. I just didn't see any of those. And I don't think that it's very likely, just kind of based on the title of the molecule. A mono, di, or triglyceride is a totally different type of molecule. A triglyceride molecule is going to have a structure that looks kind of like this, where you have these three sort of tails on the molecule. Could be oriented in that direction, or it could be oriented in a different direction. Triglyceride, because it's got three tails. A diglyceride would have two tails. A monoglyceride would have one tail. And again, I did not see any examples at all of anything other than fatty acids. If you do see that, though, please leave that information in the comments for the next student. So once we've decided that we're looking at a fatty acid, our next job is to classify it as saturated or unsaturated. These terms are referring to whether the molecule has any carbon-carbon double bonds. A saturated fatty acid is going to be one that has no carbon-carbon double bonds, or only carbon-carbon single bonds, however you want to look at it, however you want to phrase it. Please keep in mind that all fatty acids do have a carbon-oxygen double bond. We're not looking at that when we're thinking about saturation. We're only looking at carbon-carbon bonds. So saturated, only carbon-carbon single bonds, and that is what we have in this particular example. All of the carbon-carbon bonds are single bonds. Unsaturated would be one that has at least one carbon-carbon double bond, could have more. Monosaturated specifically has one carbon-carbon double bond, mono being the prefix for one, and unsaturated referring to the double bond. Polyunsaturated is going to have two or more carbon-carbon double bonds, with poly being the prefix for many. The last category, omega-3 and omega-6, these only apply if you have carbon-carbon double bonds in the molecule. So in this particular example, because I don't have any carbon-carbon double bonds, I'm not going to select omega-3 or omega-6. So I would say whichever problem you're looking at, you're going to be selecting a minimum of two boxes every single time. You're going to be selecting that it's a fatty acid, and at a minimum, you're going to select that it's a saturated molecule. Let's look at a second example where we have an unsaturated molecule and we have to use some more of these terms. So here's our second example. Again, first of all, this molecule is a fatty acid. It is not a mono, di, or triglyceride. This molecule is not a saturated molecule. If we're looking at our next category, a saturated molecule is one that contains only carbon-carbon single bonds, and we can see that I have three carbon-carbon double bonds. If I have any carbon-carbon double bonds at all, then we call the molecule unsaturated. If we're going to call the molecule unsaturated, if it is unsaturated, then we're also going to further describe the molecule as either mono or poly, unsaturated. If you have an unsaturated molecule, you have to select one of these two boxes, either mono or poly, to describe how many double bonds are present. Okay, and then also, if your molecule is unsaturated, you might be selecting one of these two boxes, perhaps. The omega designation is referring to whether or not there is a double bond present at the third carbon or the sixth carbon from the end of the carbon chain. Counting from the end, so if that's carbon number 1, that's carbon number 2, that's carbon number 3, we do have a double bond present at carbon number 3, and that makes it an omega-3 acid. And that's just all we have to do. If it was an omega-6 acid, then our double bond wouldn't show up until we get to carbon number 1, 2, 3, 4, 5, 6 right here. Now, a couple things that I've noticed when I looked at this ALEKS problem, even though I didn't see any variations, some of the molecules are in line structure like this, some of them are in condensed notation. That shouldn't stress you out at this point. Also, I did notice that ALEKS kind of goes back and forth with this omega terminology. Sometimes it writes the word out, omega. Sometimes it uses the Greek letter omega, which looks just like a fancy W. So you might see that notation as well. They mean the exact same thing. Good luck with this problem. Let me know if you see anything different.